Today we're going to do a video on how to wire a DH100 duct detector to an RTS151 key switch to be able to reset it remotely. Instead of showing you the devices, I'm going to show you the wiring diagram and what all those buttons and lines mean, because a lot of times people get to looking at diagrams and they get lost. So this right here is basically going to show you how to do that, and I've made an especially big mouse pointer so that you'll actually be able to see what in the world is actually going on. Now the DH100 has several terminals in it. They're widespread throughout it, and if I'm not mistaken there are 2 rows of them, and if you look at one row I think it's 1 through 10 and the second row is 11 through 20. And you won't be using all those. They are for other things. We're only going to be using the terminals that are actually showing on the screen right now. And this right here is the RTS151 with the 2 lights on it, the red light and the green light. And where a lot of people make a mistake is the fact that this green light here is actually supposed to be on when the unit is on. I have walked up to far too many of them and seen the green light out because they only had so many wires to tie onto it. But I can tell you right now, you need 1, 2, 3, 4, 5 wires to make this thing work correctly. If you use a an 18-4 fire wire, then is when you would say, which one can I sacrifice? And they would sacrifice the green wire. That way your green wire won't work, but your red wire will, your reset will work, your test will work, everything else will work. You just won't have a green light. What I'm showing you is the how and why that you should have that green light connected and functioning. For starters, if you go off the DH100, terminal 15 on the DH100 would go to terminal 1 of the RTS151. This is the positive lead that turns on the red light when it is in alarm. And this right here is especially useful when that duct detector goes into alarm and somebody looks at the fire panel and they've got a conventional fire panel with 6 duct detectors and is like, well, which one is it? Well, according to fire code, your reset switch is supposed to be either directly below the unit, or all your reset switches are supposed to be in a common place and each one labeled for the unit that has triggered. That is a fire and mechanical code. Well, in this particular place, let's just say this is duct detector number 1 of 6. Duct detector 1, when it's in alarm, will display a red light, and you'll be able to tell which one of those it takes to reset that duct detector instead of climbing on the roof. Because there is also another code out there that says any duct detector over 10 feet above the head, above ceiling tile, or on the roof is required to have a reset switch that you just walk up to reset it. So let's just say that this let's go back to the basics for a minute. Forget this red wire for now. What does it take to make this duct detector actually work? Well, on the duct detector itself, you'll see this box right here. And what it's trying to tell you is if you come off of terminal 19 of the duct detector, that will have 27 volts out. You come off of that and you're running into terminal 14 of the duct detector, and you'll be running through the duct detector's supervisory switch. Now, this is referred to as standalone wiring. This is not how you wire it to go through a fire panel, because when you do a fire panel, these 2 wires here terminals 14 and 13 are required to go to the fire panel, so the fire panel will enunciate the supervised report rather than just having a little light somewhere in the building and you're not knowing about it. So, being that we're wiring this as a standalone condition, being that this is wired in a standalone condition, 14 would go through the duct detector's supervisory switch and provide the power for the green light, which would tell you from below that that duct detector is on and functioning. That's where you get your green light's positive power from. And as I said before, when it comes to a duct detector that is being monitored by a fire panel, this section right here will not be used by the reset switch. It would be used by the fire panel. If I'm right, I can do this. Yep. Just to reiterate that, this section, okay, undo that. This section right here will not be used if it is being done by a fire panel. It will only be used if it's being done as a standalone device. Remember the difference. The key part about this is if it's being done by a fire panel, this wire here will instead go to here. That way you'll have your power from the aux power of the duct detector supplying power to the green LED. This supervisory circuit here is now dedicated to the fire panel, because what would happen is the alarm condition of the fire panel, and I will be doing a video on this later on that shows how the system, and I can draw it right here just for the heck of it. We'll take this guy out of the way. Bye-bye. When it comes to your fire panel, the wiring in the fire panel has the red wire, which goes out through your fire devices, and then comes back to a resistor, the EOL resistor, and your black wire. Over here. And what you have is your resistor will be right here, and your fire devices, the duct detectors themselves, will be here and here and so on. That way it goes through the alarm circuit of the resistors, or of the circuit, and then out and up to the resistor. Now you're seeing this broken line right here. This broken line is right here. Once you take this wire here and run it through the duct detector, because you're going to be running an 18.4. Once you run it through the duct detector, your red and black don't get broken going through the units, because they're actually looking for the resistor. The yellow and green, which I'll explain later, will get broken right here in each one of the duct detectors right here. That will be the breaking point. And I will show another video later on that. Make all that stuff go away. And just to reiterate, if you're doing from the through the duct detector to a fire panel, this wire instead goes to here. So we're going to backstep that for a second and just do the re-explanations on this. Now we have the wire that lights up the green light to tell it it has power. Then we have that is the aux positive. Then you have the aux negative. The aux negative will go to terminals 2 and 4. Terminal 2, if I'm not mistaken, is the negative side of the green light, and terminal 4 is the negative side of the red light. That's what gives them their negative power. That's why I show these in black. The way this system is set up, these bottom two wires for terminals 3 and 5 are your key wires. The reason why I say key wires is because the RTS has a key in it, and if you flip the key to the left, it activates I believe the reset, and what will happen is terminal 2 will create a negative signal to terminal 3 and go back to hit the reset, and it'll cause the duct detector to clear itself. If you flip it the other direction when it's in alarm, terminal 5 will catch the negative off of 4 and go back to terminal 11 to fix the test circuit. What it will do is, as long as you hold it down, the duct detector will be in alarm. But as soon as you let go of the switch, it'll go back to normal. And the easiest way to test any one of these, if you're up at the duct detector itself, you take a short wire and you can short from here to here, terminals 11 to terminal 20, and it will cause the alarm to test. You let go of it and it will stay in alarm. If it doesn't, you likely have a bad duct detector. It will stay in alarm. You put that same shorting wire from 11 and put it on 2 and hit terminal 20, and it'll cause the duct detector to reset. If those two procedures don't follow what I just said, your duct detector is bad and needs to be replaced. I would recommend doing those two tests before you run any wire anywhere to do anything. Go to the duct detector and short out terminal 11 to terminal 20 and see if it goes into alarm. If it does, short out terminal 2 to 20 and see if it resets. If it does, you're good to go and everything's going to work like it's supposed to. If they don't even bother doing anything else until the duct detector is replaced, or you'll be putting everything in and hitting that switch and it won't work, and you'll be beating that thing to death wondering what you did wrong on that switch. And you didn't do anything wrong on that switch. Do the test on the duct detector first. This is how you wire up a DH100, and I'm not even going to say you need to worry about this part right here. This is how you wire up the DH100 to an RTS151 key. If you have any comments, leave them below. If you want to, subscribe, do whatever you will. Let's get this stuff wired correctly. Talk to you later. Bye.